Hello everyone. So today we are going to start developing a custom IK resolving system for this four-leg character. So this is what we are going to do. So as you can see here, if we can lift each leg of the character like this. So for the front leg, we have defined a leg definitions for all the legs, and character can, if I keep like 0, it's like this. If I make it 0.5, it would lift the leg like this. If I make it 1, like this. Similarly, I can move up and down all the legs I want. We need to keep it between 0 and 1. Oh, this is the back. Where's the first leg? Okay, here. Not like that. Okay, like this. Right, that's what we are going to work on today. Right, so for this dynamic IK solver for this character, generic character, this is my plan. So I'm gonna create a dynamic IK solver like this. Let's define a structure to hold the bones in one leg, and then I'm going to define a maximum limit to each bone. So for example, this bone, it should be this. So right, and for the next bone, it should be this, which I can read here. Okay, so now let's go to our deer animation script, and here let me first define a data structure. Let's do it here. It should be serializable. Sorry, it should be in a class. Class leg, let's call it leg definition. Sorry, we don't need this. Okay, and this should be serializable. In order to use that, we need to use system serialize. Let's include it like this using system. Right, now for a leg, we should have a reference to the bone. So public, well, bone also should be another structure. No, public transform bone, and then yeah, actually this is not leg definition, this is the bone. Let's call it bone data. Okay, that's more suitable. And yeah, then public vector 3 rotation. So here I'm going to use for each bone we need to have some rotation, so that I'm gonna use as the initial rotation. Right, no, let's call it neutral rotation, because without any IK that should be the rotation in the idle mode. So similarly another one, max rotation. Okay, so now this is the bone data, and inside my main class I'll define, well, now these things, these are for testing. No, these two were for testing, so I'll comment them just to make sure if everything is working fine. Let's play and see. Yeah, it's fine. Okay. Now I'm going to delete this tr hand, tr forearm. We don't need those things anymore. Instead, I'll create a new variable, public bone data, should be an array, leg, well, yeah, leg definition. Oh wait, maybe no, in order to define a leg we need, yeah, at least like in a two bone IK system we need two bones that bend and one leaf. So right, then let me delete this. Let me create another serializable class like this. It shouldn't be bone data, it should be leg definition. No, let's call it two bone IK. No, that's deer leg. Okay, that's better, clear. And public bone data, top bone, public bone data, mid bone, public bone data, toe. Right, so instead of top bone, what should we call it? Upper bone, no, forearm, that's the hand, and finger. This is finger, this is hand, this is forearm. Okay, this would be enough. Top bone, mid bone, toe. Now we don't need this also. What's this? Now let's define public leg deer leg definitions. sorry, dear leg definitions. Okay, now let's see. Okay, now under leg definitions I'll make this 1, and as the top bone let's assign, so let's start with the front. Let me rotate the character to have a clear effect. Top bone is left forearm, mid bone is left hand, and the toe bone is this finger 0. Okay, right, so now let's test this. Yeah, before that we need to define this neutral rotation and max rotation. Let's start with the L forearm. So the neutral rotation is this. Copy Euler angles, and paste. Oh, okay. Max rotation is make sure that you are in the global rotation and rotate it like this. I'll take this as the max rotation. Copy, undo, paste. Right, similarly let's go to the midboard. This is the neutral rotation. Paste. The max rotation. Let's take it as this. Because that's the way this bone bends, as I know. Copy and paste. So for the toe we are not at the moment, I am not trying to bend it or do any modifications, so we don't need neutral or max rotations for that. Right, now here let's define another function for this leg IK solving. Void void leg IK. Let's call it solve leg IKs. Okay, now for dear leg in the collection is leg definitions, right? So how do we bend the leg? Well, let's add two more variables here: public float lift length. So this is the amount we need to lift our leg in order to match with the ground. So yeah, public float lift percentage. Okay, and then for testing I will use only this lift percentage. Let me collapse this initial stuff, and here let's call, oh, wait, where do we call this? Okay, solve, no, what's the function name? Solve leg, I guess. Sorry, this should be solve. Right. Then here for the leg dot top bone dot rotation. No, we need to modify this bone. So I'm gonna get a reference to this bone and set the local rotation like this. So first I'm gonna get the local rotation and add leg dot top bone dot max rotation sorry, this should be Euler angles, no, local Euler angles, and this also should be local Euler angles, right? Then I need to get the difference between the max rotation and the neutral rotation of the top bone. So leg top bone dot neutral rotation and multiply with this, multiply this amount with the leg dot top, no, leg dot lift percentage. We need to do that to the mid bone as well. Mid bone Now let's test this. Okay, here we don't see anything different because I set the lift percentage to 0. If I set it to 0.5, oh, becomes like this. Okay, it's right. Why does it bend in that way? Well, let's troubleshoot the system. So yeah, let's keep the lift percentage at 1, and for now I'll comment the modification of the mid board. So if the top bone is working correctly, it should bend like this. So it should have this 16,1,117 as the result. Let's see, 16,1,117. Yeah, it's something close. All right. Now if the about the left hand, so here the rotation is minus 93, 40, minus 6, but when I let me disable this for a second. Let's make it 0, and when I play, if I select the left hand, you can see this value is very different from what I had in the editor. So I'll copy this value and change it like this for the initial rotation. Okay, and then let's use that value here. Neutral rotation is wait, let me copy again this value. Okay, and the max rotation is 356, 108, 285. Let's see if that is correct. No. Right, now this is the max angle. Wait. One 86, 68, 1110. Oh, that's not the value I get here. Why is that? Alright, so why can't I get that value? Anyway, let's now uncomment this part and comment the top leg modification part, and let's set this to 1 and see. Oh, That's the case. It's not bending in the way I imagined. Right. 86 minus 86. Copy. Oh, this is something else. Let me just manually type it. Right, so finally I manually typed in the values. So neutral rotation is this and max rotation is this. So okay, here yeah, I have enabled only the modification for the main board. So for the lift percentage one, now it is like this. Okay, now let's enable the top one as well. Right, it looks like this. So this is the maximum amount the character can lift his leg. Okay, does it look natural though? All right, let's see. Right, now just like this, let's add 4 leg definitions for all the legs. Element 1 is right hand. Here oh, this is back. Okay, right forearm. Top one should be right forearm, not upper arm, the forearm. And the mid bone should be right hand, and this is right finger. All right. Now for the neutral rotation of the right forearm. 0038. Sorry, here. Okay. Max rotation. 3 minus 8, 1, 2, 2. 3 minus 8, 1, 2, 2. right hand. Is this the same value when I play the animation as well? So let's make the lift percentage to 0 and play and see. Right hand 96, 96 minus 50 minus 45. Okay. Now I don't remember. 96 minus 45 minus 40. 96 minus 45 minus 45. Max rotation should be, let's see, 177, 84, 88. Okay, now let's set the lift percentage to 1 and test. Oh, that's wrong. We'll make this minus there. Right, that's correct. Wait, what happened to the other leg? The left one. Alright, what happened wrong? What wrong with the first one is because in this element 2 and 3 also I have set that one. So how to clear it? Yeah, basically set this as 2. It should be alright. Okay. Well, there are some differences in the values I have used for the max and neutral, but we should be able to fix it. Let's leave it like this. Okay, now that's all for the front legs. So let's move on to back legs. I'll make it 3. Okay, now for the back leg, let's start with left. Top one is L calf. then L host link, then L foot. Okay, so the values, L curve, let's use this 0 0 58. Let's see if there is any difference when we play the animations too. Nothing. Cool. 0 0 58. So that's the value we are going to use. And for the max one, let me set everything else to 0 so I don't make any mistakes. Max rotation for the left calf, is so where does it bend? It bends this way. Yeah, so maximum rotation I'll take it as this, 10 minus 17 115. 10 minus 17 115. Okay, let's make it 1 and see. Okay, and the mid bone for the back left leg is this one. What's the maximum it can bend? I'll take it as this. Twenty-two 0 to 5, 22 0 minus 133. 22 0 minus 133. Oh, what's the neutral value? 0 0 minus 65. Does that change? Minus 65. Okay, let's see now. All right, I think that's the way it works. Okay, and one more leg to go. 4. Let's make everything 0. Top bone is our calf, our horse link, our foot. Our calf 58. Max rotation, let's take it as 0. 0, no, minus 2 3 1 2 1. Okay, host link minus 65, maximum rotation is minus 4 0 minus 1 to 9. Cool. Now this is at the maximum bend this character can have. So right, I think we can stop this episode here, and in the next episode let's see how to dynamically change this lifting percentage and solve the IK values. Alright, so if you like to support my work, you can get the membership of the Patreon club. Link would be in the description below. And thanks for watching. See you in another episode. Goodbye. Oh, almost forgot. This episode is sponsored by this generous patron. Thank you very much for your support.